My dear students, now we are going to look at design of 4-bit asynchronous up counter. So in this up counter, what we try to do is we will look at the design steps, then followed by the state diagram. Okay. What we do is here, normally we are designing with 3 flip-flop, but in this case, what we try to do is we design with a JK flip-flop. Okay. So number of flip-flops required, we can make a calculation, but here not required, because it is clearly given that it is a 4-bit asynchronous up counter. So 4 flip-flops required. I would like to use JK flip-flop. Okay, we can draw the state diagram. We can look at the truth table. Then, do we need any reset logic here? No need of reset logic, because we are not terminating the count sequence in between. It is also known as mod 16 counter. Okay, anything between mod 1 to mod 16, let's suppose, say mod 2, mod 3, mod 4. Okay, anything. It is not 2 power n value, mod n value. So if n is equals to 2 power n, okay, we don't require any reset logic, because we are using all the possible values. That means to say, if it is a 3-bit, 3 zeros to 3 ones you are going. If it is a 4-bit, 4 zeros to 4 ones you are going. So no need of stopping in between. So no need of reset logic. No need to reset. No need to restart. Okay. Reset is to restart. So no need of this logic. No need of this logic in this application. In this case. Next, if we are using JK flip flop, how we can use JK flip flop as a toggle flip flop? When J and K are connected together, and if is connected to 1, okay, then it is going to act as a toggle flip flop. Acts as a flip flop. Because we need a counter. Counter is always should able to toggle. It has to change its states, so that I am going to get the required transitions. Okay. To get the required transitions, what we are trying to do is one flip flop output will be connected to clock input of the next flip flop. Okay. For very first flip flop, we are going to apply the clock. That itself is going to act as a LSB. Later on, we are going to get MSBs. Okay. Then once the circuit design is done, okay, once circuit design is clear, what we try to do is we look at the timing diagram. Okay. So what we try to do is just look at the state diagram. State diagram, I need not pay much attention on this, because you are very aware of this. We know, everyone knows this. So 0 0 0, because it's a 4-bit, 0 0 0 0 1. Okay. So then for the rest of the cases you need to do it. Of course, how to do it we don't know. You know, right? Okay. So you can proceed. Okay. Once you proceed, then you will get your state diagram. I'm not drawing here, just to save the time, because which is known to you. So what I try to do is just I'll put a dot, right? Then a last state, which is 1 1 1 1 1 1. Then go to 0 0 0. Okay. This is your state diagram. Now if you look at it, how exactly it works, it's something like this. So it is going from 0 0 0 0 0 to 0 0 0 0 1. That is best of counting. Okay, for the clock one. So what I try to do is clock. Okay. So for clock 1, it is going to change from 0 to 1. For clock 2, clock 3, clock 4, likewise I can write all numbers, so it comes out to be 60. Okay. What is the input to this circuit? This is input. What is the output? Output is, it is moving from one state to the other state. Presently it is at 0, so this is what exactly the output. What is output is moving from current state to next state. So the next state becomes the present state. So this is not somewhere here. So what is the meaning of this is, this is 0 0 0 0. It will become 0 0 1, means it will get updated here. That means it will become this. From here it is moved to here. Only for the sake of understanding. Okay, shown as a separate table next state, but actually it will move in this. That means only this flip-flop will get updated. Remaining 3 will be remain. What I mean to say is, these 3 flip-flops remain same. This flip-flop will only going to change from 0 to 1. Then the next case, this is not going to change, but this is will get updated. This remains same. Okay. So it is happening there itself, in the same flip-flop content itself. Okay. So to make it simple and to understand, okay, this is what exactly the meaning. That is going from 0000 to 001, 001 to 010. The meaning of this is it is changing at the same time. What is the meaning of that is, before application of clock it is QA, after application of clock it is QA plus 1. For the next clock, QA plus 1 is nothing but QA for the second clock. That means QA has got updated to QA plus 1. Then we are calling it as QA. Then for the next clock pulse, QA will get to QA plus 1. So QA and QA plus 1 we are calling same content. That means if I take flip-flop A, if I take the clock, okay, if I go and apply the clock, okay, what is the QA is, say for example negative going edge. At this, before this it is QA, now it is QA plus 1. For next, with respect to next clock pulse, it is QA, and whatever you get after that is QA plus 1. So what is there at QA plus 1 is considered as QA with respect to next clock trigger. Now this is next clock trigger is somewhere here. Okay. So when next clock trigger is here, this is QA plus 1 with respect to this clock. Okay. So for respect to this trigger, now it becomes QA. Then what exactly that I'm going to get next is QA plus 1. So what I mean to say is, QA will get updated upon application of the clock. The updated value is nothing but QA with respect to the next clock. Okay, this is one has to understand. What is the meaning of that is, QA upon application of the clock. Okay, what we are calling it as QA plus 1. Okay, that is nothing but QA itself, QA getting updated. So before updation it is called QA, after updation it is called QA plus 1. Then for the next updation, QA plus 1 itself is called QA, then it will get updated. So this one has to know. Once this is clear, it is very simple. Now what exactly do we need to clear the flip-flops when the count sequence is going on? No, we don't require any such things. So what we try to do is, so what is required for us is something like this. Do we need to clear the things? No. So since we don't require the clearing of flip-flops in between, what I can say here is, always the CL, the clear, actually I will write in details clear. So in short I have written as CL. Okay. So always this should be 1. What is the meaning of that? We don't want to clear. Actually what is clear? Active low input. Okay. So because it is active low input, so it is, when clear is equals to 0, it clears. When clear is equals to 1, it is not going to clear. What is going to happen? It is going to update the counts as per the clock. Okay, clock is there, clock input is triggered, then next go to the next step. So let us look at the clear. So what exactly the clear? So clear, which is CL, which is always 1. So 1 1 1 1 1 1 1. From where we are getting this? From QA cubic. This is we are getting from QA, QB, QC and QD. So it is always 1. That means in any counter, when we are going from complete count, I am not going to clear the flip-flops at any instant of time. My clear should be always 1. Okay. Now if I take a JK flip-flop, for example, if I connect clear is equals to, this is clear, is equals to 1. Preset is equals to 1. What is the meaning of this? You don't want to clear, you don't want to put something. You don't want to load 0, you don't want to load 1. This is loading 1, this is loading 0. When they are low, I should call it as preset bar and clear bar can also call it. Okay, because it which indicates that when it is low it is going to active. Okay, so what exactly that is, if I give a clock input here, if J and K are connected together and if we made it equal to 1, okay, in this case JK flip flop go on changing its states. So if initially if it is 0, it will become 1, then it will become 0, it will become 1. So this is how it is going to update its value as the clock is applied, okay, because JK is equals to 1, it is going to act as a toggle flip flop. Now why I am taking all these things is, what I would like to say is, here clear, whatever is there clear, bar is there or not, depends on the convention or the P. Okay, what sort of convention that we are using. Now I am saying clear, okay, press. So clear is active low signal in words I am saying. So when clear is 0, it clears. But what we are doing, what we got it, the clear, which is we are calling as CL, CL is always 1. That means you don't want to clear in between. Okay, if CL is equal to 0, we are going to clear. If preset is equal to 0, we are going to preset. Okay, so this is what exactly the thing. So next what we need to do is, we need to build the circuit. So we have 4 JK flip flops. You take the 4 JK flip flops. Then what we need to do is, just we need to connect the flip flops. So far we have built the circuit using JK flip, not using JK, just using T flip flop. So connect all J and K's, connect it to 1, connect J and K, connect it to 1, logic 1, connect J and K, connect it to logic 1, connect J and K, connect J and K, connect it to logic 1. So all presets, okay, whether it is shown or not shown, it is understood that for a normal counting sequence, full counting sequence, okay, it is connected to 1. All clears, okay, by default if it is not even being shown, by default it is connected to 1, then only counting is possible. Now output of this flip flop is input to the next flip flop, output of this flip flop is input to the next flip flop, clock, output of this is clock input to the next flip flop, right? So this is J, K, J, K, J, K, J, K. This is flip flop A, flip flop B, flip flop C, flip flop D. Okay. Now where you will take the output? Let's take the output from QA, QB. This is QB, and from here it is QC. Then here, from here I am going to get QD. Okay. QA is LSB, QD is MSB. So how your output will be? QA, QB, QC and QD. Okay. This is how an up counter can be built. So if you look at this here, it is Q, Q bar, Q, Q bar, Q, Q bar, Q, Q bar. We have seen the timing diagram with respect to what? With respect to 3 input, 3 bit asynchronous up counter. Whatever you have seen there is applicable for this also. Okay. So I need not to spend time on it. Just you can work it out how to draw the, okay, the timing diagram. What I need to do, just you need to take a clock, draw the clock, then get output for flip flop A, then use flip flop A output as a clock input to flip flop B, flip flop C and flip flop D. I have taught you how to draw. Okay, I hope you can do it.